All right, so before we dive into notes today, if you missed the Explore activity in class, you kind of missed the build up into solving systems graphically. So I'm just going to kind of recap what we covered. If we're given a system of equations, we're going to get two equations here. And what we can do to solve them graphically is plot them, which I'm going to go do in Desmos. So y equals negative 3x plus 4. And y equals 3x minus 2. Double check that I entered that correctly. And it looks like if we do that, we have this green line, we have this purple line. Your colors may be different, but this intersection point here, if we click on this gray dot at 1, 1, that is the solution to our equation. X is equal to 1 and y is equal to 1. So in this case, our answer is 1, 1. And let's remember that that first number is our x value. That second number is our y value. So if you do this again, let's do it for, let's say, number 3. Let's do that one as a group real quick. If we plug that into our Desmos, so 2x minus 3y equals negative 1. X minus 3y equals negative 1. And the second one, y equals x minus 1. Okay, you can see that we have an intersection point over here. It's over at x equals 4. It's over at y equals 3. So the solution to our system is 4, 3 for our x and our y values there. Let me write that in. 4, 3. I'd recommend trying that out for 2 and 4 just so that you can get some additional practice. But when we go through examples, I recommend having Desmos up and checking your answers with Desmos as well. All right, let's move on to our notes section then. So this should match the top of your note sheet. We're going to quickly get a definition down for system of linear equations. Simply a set of 2 or more linear equations. And linear means we're not going to have any exponents involved in it. All right, this is just a quick one-day review of some stuff that you probably covered in Math 1 and 2, but it's going to build into what we cover tomorrow as well. So there's 3 different possible number of solutions here. The first one is when we get an intersection. If we get an intersection, we're going to have one solution. And you can see down here for this graph, we have a intersection at negative 2 and 1. And so our solution is negative 2, 1. Okay, we can also have a instance where there's no solutions. Notice how the red line here and the purple line and the blue line never cross. Okay, they're parallel. That would be an example where we have no solutions. And there is a scenario where we can have an infinite number of solutions. And if you notice this, the blue and the red line on this here are the same line. They are on top of each other. So any value of x, any value of y for those functions would give you a solution. All right, the next thing we should get down on our notes are the steps to solving a system using the substitution method. So it's most important that you understand graphically what's going on, but I think it's also good to have a good idea of the process algebraically, which we're going to work on for the rest of class. So step 1 is to solve one linear equation for y in terms of x. This is sometimes done already. We'll see that in our first 2 examples. Then we substitute that expression for y in the other equation. We'll solve this and we'll come up with the x-coordinate. And then we'll plug that x into either equation to find the y. So it's going to show up in a variety of ways in our example problems. This first one, y equals negative 3x plus 4, y equals 3x minus 2. In this case, we actually have 2 equations for y that we can simply substitute in and get a really nice clean equation here. If we substitute in this y to replace the y in the first equation, here's what we get. We get 3x minus 2 equals negative 3x plus 4. Then we're going to want to move some stuff around to get all numbers on both sides, or all variables on one side and all numbers on the other. So I'm going to add 3x to both sides. I'll get 6x minus 2 equals 4. Then we can add 2 to both sides to move that 2 over. I'll get 6x equals 6. And if we divide by 6 here, okay, we'll get x equals 1. So that's part of our solution, right? X equals 1. But now we need to plug it back into our original equation. Your note sheet is working down vertical. I'm going to slide to the right just so I have space and you can see what's going on here. I'm going to take this right here and plug it into, let's say, that blue equation again, the y equals 3x minus 2. So if we do y equals 3x, in this case it's 1, 3 times 1 minus 2, we get an answer of y equals 3 times 1 is 3, minus 2 is 1. In this case, y equals 1. And if you go and graph this in Desmos, you can see that that's exactly the same solution we'll get. I'll go jump to that now real quick. So I've jumped to Desmos, I've graphed it over here. We have an intersection at 1, 1 where x equals 1 and y equals 1. So that's a good way to check our work and say, hey, our solution here is at 1, 1. And I'm going to throw a box around it to kind of demonstrate that that's our final answer, because we do have a lot of scratch work leading up to that problem. So let's try this on your own in example 2. I would recommend pausing your screen, working through it, unpausing and checking against mine. Here we get another scenario where we can just plug stuff in right off the bat. We have the y's equal to each other, so let's go with x plus 3 equals negative 4x plus 2. I'm going to start moving stuff over, plus 5x on both sides. I'll get 6x plus 3 equals 2. Now I'll try to get the numbers over on the right, so subtract 3 on both sides. I'll get 6x equals 2 minus 3 is negative 1. And I'm actually noticing as I go through that that's not a super clean example, so let's change this to a 7. Let's do, for example 2, y equals x plus 7. So if we plug that in, we get x plus 7 equals negative 4x plus 2. Okay, we'll add 4x to both sides. We'll get 5x plus 7 equals 2. We'll subtract 7 from both sides. We'll get 5x equals negative 5. And that will give us, if we divide by 5 on both sides, an x value of negative 1. So that's part of our answer. Now we got to plug it back into one of our equations. Let's just take it as y equals x plus 7. So in this case, we'll take y equals negative 1 plus 7. And that means that y equals 6. And that gives us a solution of negative 1, 6. And I'll throw a box around that just so we have that nice and clean. And if we wanted to go and check with Desmos, if we graphed it here, okay, you can see that our lines intersect at negative 1, 6. So we're good there. All right, so we continue working here. This one's a little more complicated because we don't have both equations set equal to y. So let's swap out this equation, y equals x minus 1. Let's plug it into that y in our second equation. So we'll get 2x minus 3, and this will be a little complicated here because we'll have to use parentheses, x minus 1 equals negative 1. We want that entire equation for y to swap in. And then so in this case, we're actually going to have to distribute in and multiply as our next step here. So we get 2x minus 3x plus 3 equals negative 1. And then we can start solving. We get a negative x over here. We can subtract 3 from both sides. Oh, let me go back a little bit. We get that negative x. We're just going to drop down that plus 3 equals negative 1. And then we can move that negative 3 over to the other side. So minus 3 minus 3. and we'll get negative x equals negative 4. And if negative x equals negative 4, then positive x equals a positive 4 there. So that's part of our first answer. And if we just plug it back into our y equation, y equals 4 minus 1, we'll get a y value of 3. And then our solution is going to be 4, 3. And if you check in Desmos to see what you got there, that indeed has an intersection at x equals 4 and y equals 3. So it looks like we did the math correctly there. All right, let's do one more. This one will be kind of the most complicated type. You'll notice that neither of our y equation, or neither of our y's are isolated, so we're going to have to actually move something around first. So what I'm going to do is I'm going to take this first one here, 2x plus y equals 20. I'm going to take that, and I am going to solve for y. So I can slide this negative 2x over. We'll get y equals 20 minus 2x. And now this is something that I can plug in to our one of our original equations over here, and we'll get 6x minus 5 times all of that, the 20 minus 2x, equals 12. We'll have to distribute again with that 5, so we'll get 6x minus 5 times 20 is 100, plus 10x equals 12. We can start combining stuff, so 16x minus 100 equals 12. We'll move that 100 over. So adding it to both sides there, we get 16x equals 112. And if we divided out 16 on both sides, we will get x equals 7. And now this is something that we can actually plug into this newer equation that we made. We rearranged and solved for y. We can plug that in to get y equals 20 minus 2 times 7. And in this case, it will be y equals, not 14, sorry, y equals 6. And then we can check our answer in Desmos to see if that's correct. In this case, the solution is 7, 6.